Everyone's sure they know what speed means, but do we really? In everyday life, we only ever talk about miles per hour. We've all heard of the speed of light in school, but let's be honest, our understanding is purely theoretical. So what would actually happen to a person traveling at the speed of light? The truth is, the human brain is too lazy to ask complicated questions, especially if there's no personal gain in finding the answers. The first real scientific breakthrough about the speed of light came in 1905, when Albert Einstein introduced his special theory of relativity. This theory was meant to explain exactly what happens when you move close to light speed. Einstein realized at such speeds, time and space themselves begin to change, because the speed of light is a universal constant. That's why he came up with the famous equation E equals mc squared, where E is the total energy of an object, m is its mass, and c is the speed of light in a vacuum. And here's the mind-blowing part. As you get closer to light speed, your mass increases toward infinity, your length in the direction of travel shrinks almost to zero, and time for you slows down. From an outsider's point of view, it could practically stop. So just how fast is the speed of light? After Einstein's theory, scientists spent decades refining the number. By 1977, they'd measured it with incredible precision, 186,282 miles per second, with an uncertainty of only about plus or minus 0.75 miles per second. Will we ever be able to travel at that speed? Maybe someday, or maybe not. It might be the one frontier that human progress can never cross. One thing is certain, reaching the speed of light is impossible for any object with mass, and going faster? Forget it. But here's the real kicker. It's not just physics that stops us, it's space itself. Imagine someone magically reaches light speed. What happens? They'd be dead in seconds. And no, it's not because of relativity, it's something far more dangerous. Outer space isn't empty. It's filled with an extremely thin gas, about 90% hydrogen atoms and 10% helium. The density is tiny, just a few atoms per cubic centimeter. But at light speed, even a single hydrogen atom turns into a deadly particle beam. When those atoms hit a spaceship or a human body, they carry about 7 tera-electronvolts of energy. That's the same energy as protons in the Large Hadron Collider at full power. Seriously. And that's not even the worst part. These collisions cause intense ionizing radiation, tearing apart molecules, shredding DNA, and destroying living cells instantly. To put it in perspective, a lethal radiation dose for a human is around 6 to 10 sieverts. At light speed, you'd absorb millions of times more than that in just a couple of seconds. This might actually explain why we've never been visited by aliens. No living being can survive light speed travel, no matter what it's made of. Protein, silicone, or something we can't even imagine, it all gets obliterated. So maybe the speed of light isn't just a physical limit. Maybe it's also a cosmic safety barrier, protecting life from destroying itself in the race to the stars. Subscribe to the channel. It only gets more interesting from here.